this experiment 14A, the hot and cold water stream enter the shell and tube heat exchanger counter currently.
We shall study the effect of cold water flow rate on the heat transfer coefficient at constant hot water flow rate.
Perform the general setup procedures as in section 14.1. Switch on pump 1 and pump 2. Open and adjust valve 1 to 8 to obtain the desired flow rates for hot and cold water streams. Bleed any air trap inside the differential pressure lines. For this experiment 14A, the hot water flow rate are being kept constant at 20 liters per minute, while the cold water flow rate varied at 4, 8, 12, 16 and 20 liters per minute. Allow the system to reach steady state. Record all the temperature for hot and cold water stream and also the differential pressure for pump 1 and pump 2.
In this experiment 14B, hot water and cold water enter the flow streams of shell and tube heat exchanger counter currently.
We have to study on the hot water flow rate at heat transfer coefficient constant cold water flow rate.
For this experiment 14B, cold water flow rate are being kept constant at 10 liters per minute, while the hot water flow rate varied at 8, 16, 24, 32, and 40 liters per minute. Same as previous experiment, the inlet and outlet temperature for both hot water and cold water stream and also the differential pressure for pump 1 and pump 2 are being recorded.
In this experiment 14C, hot water and cold water enter the shell and tube heat exchanger counter currently. We shall study the effects of hot water inlet temperature on the heat transfer coefficient and constant hot water and cold water flow rate.
For this experiment 14C, both hot water flow rate and cold water flow rate are being kept constant at 20 liters per minute and 10 liters per minute respectively. But we are changing the temperature from 50 to 55, 60, 65 degrees Celsius. Allow the system to reach steady state. Record all the temperature for hot and cold water stream and also the differential pressure for pump 1 and pump 2. At the end of the experiment, switch off the heater, both pump P1 and P2, main power, retain the water inside the hot water and cold water tank for the next laboratory session, and also close all the valves. Based on the above graph of overall heat coefficient against cold water flow rate, we can see that as cold water flow rate increases, the overall heat coefficient will also increase. This is because when the cold water flow rate increases, the amount of heat transfer from cold water to hot water is also increased. According to the formula, Q cold equal to mass flow rate cold times by Tc out minus Tc in. Based on the above graph for 14B of overall heat transfer coefficient against temperature setting, it's shown that the temperature setting of hot stream inlet of heat exchanger is directionally proportional to the overall heat transfer coefficient. When the temperature setting gets higher, the temperature difference between the inlet and outlet increases for both streams. Hence, the heat transfer rate calculated is larger according to the formula, which includes the temperature difference between inlet and outlet temperature. Based on the graph for 14C, when heat transfer is increased due to increasing of hot water inlet temperature setting, it is assumed that the overall heat transfer coefficient will also increase, according to the formula. As stated in the formula, the overall heat transfer coefficient U is directly proportional to the heat transfer Q.